Hello everyone, I am giving here to give introduction to supply voltage. Supply voltage impacts the power consumption in several ways. The charge stored on the capacitive load is proportional to the square of supply voltage. So higher supply voltage means greater charge stored on the capacitor during charging. This in turn means flow of higher amount of charge from VDD to ground via load capacitor. So switching power is proportional to the square of supply voltage. The leakage current flowing through the reverse bias junction, that is off transistor, is dependent on the supply voltage. Higher supply voltage would mean higher leakage current. When an instantaneous short circuit is established due to input transitioning, the transistors taking part in this short circuit path behave like resistive components. Hence, the short circuit current flowing through these transistors would depend on the supply voltage. Higher value of VDD would mean a higher current flow. So, short circuit power is proportional to the square of supply voltage. Components in the critical path need to work at higher voltage. Lower voltage may be used for components lying on path with enough timing slack. So for a design having multiple voltage domains, we need signals going from lower voltage to a higher voltage and vice versa. This can have an impact on noise margin, thus reducing the reliability. In the 0.8 volt domain, the switching threshold at half VDD is 0.4 volt, which means a noise margin of 0.4 volt. In the 1.1 volt domain, the switching threshold is at 0.65 volt. So when a high signal at 0.8 volt signal reaches this 1.1 volt domain, the noise margin is reduced to just 0.15 volt. Hence, there is a need to put in a level shifter when a signal moves from one voltage to another voltage. Figure shown below shows the signal moving from one voltage to another through a level shifter. So here, in the given diagram, we need to move a voltage from 0.8 volt to 1.1 volt level. So we can see that here we are making use of a level shifter for the signal crossing from 0.8 volt to 1.1 volt. For each combination of source and destination voltage levels, a different kind of shifter should be used. For example, the shifter used for 0.8 volt to 1.1 volt is different from the one used for 1.1 volt to 0.8 volt. The difference is just not for low to high voltage levels versus high to low voltage levels. Rather, each unique pair needs to have its own shifter. Sometimes there might be situation of a lower voltage signal entering a module of higher voltage, but there is no need for a level shifter. Figure shown below shows some situations where level shifters might be needed or might not be needed. So here in the diagram we can see that in the top we don't need any level shifter for switching voltage. Thank you.